Hey students, welcome to mathgotserved.com. In this clip, we're going to be going over how to solve exponential equations. Alright, the instructions for problems 1 to 3 are for us to solve the exponential equations for the exact solutions. Alright, so let's consider problem 1. Let's say we have 5 raised to the x power equals 625. First question we're going to ask ourselves, since we're looking for the exact solution, is that can I express the number on the right as a power or as an exponent with the same base as the exponential term to the left? So that's the question. Can I write 625 as 5 to a certain power? So let's go ahead and go over the powers of 5 and see if we could run across 625. So the first one, 5 to the first power is 5. 5 to the second power, 5 times 5 is 25. 5 to the third power is 125 times 5. 100 plus 25, which is 125. And then we have 5 to the fourth power, 125 times 5. If you carry out the multiplication, you end up with 625, and that's exactly what we're looking for. Now we'll proceed to express both sides as exponents with a base of 5. So we have 5 to the x power on the left side equals 5 to the fourth power on the right side. Now what you can do is simply cancel out the two bases and equate the exponents, but let me show you what justifies that move. What you're going to do is basically take log base 5 of both sides of the equation. So this format of expressing the next step shows you the inverse relationship between exponents and logs. Remember that exponents and logs are inverses, so these ones cancel out. So we have x equals, on the right side, log base 5 and exponents with a base of 5. The log takes out the exponent's base, and you're left with the power. So our final answer is x equals 4. Now let's take a look at question number 2. What if we have 1/3 raised to the x power equals 81? Okay. Now the goal is to try to express both sides as exponents with the same base. If I can do that, then I can use logarithm base to cancel out the bases and equate the exponents to get my final result. Now let's take a look at the left side. We have 1/3. I can express 1/3 using the reciprocal property of exponents as 3 to the negative 1. Okay, and raise that to the x power. And then we have 81 on the right side. Now using the power of a power property, if you have a power raised to a power, all you simply do is multiply the powers. So we have negative 1 times x as a simplification of the left side of this equation. So you have 3 to the x equals 81. Now, can I express 81 as a power of 3? Let's go over our powers of 3, okay? So 3 to the first power is 3. Let's not forget 3 to the 0th power is 1. That's important in some problems. 3 to the second power is 9. 3 to the third power is 27. And 3 to the fourth power, 27 times 3 is 81. This is the one we're looking for. So we're going to rewrite this equation as powers of 3 on both sides. So 3 to the x is equal to 3 to the fourth power. And then if we take log base 3, just to show you the steps, you don't have to do this. Take log base 3 on both sides of the equation. That shows you what's going to happen next. Taking log base 3 of both sides of the equation eliminates the bases of the exponential terms that we have on both sides, like that, and we're left with, oh, I left something out. We have, if you multiply these two, we have a negative here, so let's not forget that negative. Put it back in. Okay, so we're going to have negative x is equal to 4. All right? Now, let's finish this off. To get x isolated, we divide both sides by negative 1. And our final answer is going to be x equals negative 4. Alrighty, so that's the solution to question number 2. Now let's take a look at question 3. What if we have the equation 5 to the 2x plus 1 equals 125? Now we already have 5 as a power here. 5 is prime, so we can't do anything more with this. But can we express 125 as a power of 5? And the answer is yes. If you go back to the other list of powers of 5 that we have, you'll find out that 5 raised to the third power is 125. Now we have exponents with the same base on both sides, which is excellent. So I'm going to take log base 5 of the left side of the equation and log base 5 of the right side of the equation. That shows the reason why we can cancel out the bases in an exponential equation where the bases of terms on both sides are identical. Alright, so we have the cancellation happening here. Cancel, cancel, because they're inverses. And we're left with 2x plus 1 equals 3. Now to finish this off, we'll just subtract 1 and divide by 2. So let's subtract 1 from both sides. That yields 2x equals 2. And then when we divide both sides by 2, we get our final result, x equals 1, as a solution to our exponential equation. Okay, now for problems 4, 5, and 6, we're going to be solving exponential equations with the aid of our calculators. Okay, so the instructions are for us to solve and round your results. Solve and round your answers to 4 decimal places. Okay, first question, 4 is 4 to the 2x equals 200. Now for this problem, the reason why we need a calculator to finish the problem solving process is because we might not be able or will not be able to express both sides as an exponent with identical bases. So if you look at the left side, we have 4 to the 2x. If you look at all the powers of 4, you're not going to hit 200. Let me illustrate for you, okay? So let's assume that we wanted to solve this for the exact answer. So we want to express 200 as a power of 4. So we have 4 to the 0th power is 1. 4 to the first power is 4. 4 to the second power, 4 times 4 is 16. 4 to the third power, 16 times 4 is 64. 4 to the fourth power is 256. So you see that 200 is somewhere here. We do not have 200 as a power of 4. There's no 200 as an output on this list of powers of 4. So 200 cannot be written as a power of 4. In cases like this, you will have to use a calculator to find the answer. You will get an approximate result. So in order to power down this exponential term to x, we can either use the common log, log base 10, or the natural log, log base e. So let's go ahead and use the natural log because I like that better. Doesn't really matter which one you use, you will get the same answer. So I'll take log base e, or the natural log of both sides of my equation. No cancellation happens here because none of these bases are e. Now we're going to power down the exponent on the left side. So that's one of the properties of logarithms. I can power that down to yield 2x times the natural logarithm of 4 equals the natural logarithm of 200. Now one might ask, why didn't we pick log base 4 or some other log base 200? Well, when you're solving equations like this involving the use of the calculator, most calculators just have the natural logarithm or log base 10. So if you want to enter it into the calculator and you don't have it in one of those formats, you will not be able to solve the problem. So I chose ln or log base e because it would give me an expression that I can input into the calculator, as you will see momentarily. Now the goal is to get x isolated since it is no longer an exponent. It's actually what's being multiplied by ln of 4. So we're now going to go ahead and divide by the appropriate numerical values to result in the isolation of x on the left side of the equation. So we're going to divide by 2 times the natural logarithm of 4 on both sides. Why did we do that? If you examine the left side of the equation, these two 2's divide out, and the natural logarithm of 4 divides out also. So on the left side, we're left with x equals the natural logarithm of 200 divided by 2 times the natural logarithm of 4. Now to get our approximate result, we'll simply enter this division statement in our calculator. Okay, so we have the natural logarithm of, where are you? Right there, above common log, the natural logarithm of 200. Now this is something that's very important. Whenever you're dividing and you have multiple terms in your denominator, you have to group them together in a parenthesis, or else you will have a syntax error. Not a syntax error, but your calculator will group it incorrectly. Okay, so you have a grouping error and you get a wrong answer. So if you notice, I am placing 2 and the natural logarithm of 4 in their own parentheses. Alrighty, and our answer is going to be 1.911 to 4 decimal places. So x equals 1.911. Alright, let's take a look at question number 5. This is another calculator problem. Now what if we are to solve the exponential equation 200 times 1 plus 0.04 raised to the x power divided by 0.04 equals 10,000. Okay, so the goal here when you're dealing with exponential equations of this nature is to isolate the term with the exponential variable, okay, the exponential term. So this term right here, we will try to isolate that. Then when that term with the variable exponent is isolated, we can proceed to use the appropriate inversion approach to get x isolated. Okay, so let's go ahead and do that. So first things first, let's see. We can divide both sides of our equation by 200. So divide both sides by 200 or multiply by 1 over 200 is exactly the same thing. So if I divide by 200 on both sides, on the left side we have some cancellation action happening. 1 plus 0.04 is 1.04 raised to the x power divided by 0.04. On the right side, we have 10,000 divided by 200. We can divide out the zeros. 100 divided by 2 is 50. Now we're going to multiply both sides of our equation by 0.04. Why are we doing this? Remember, the goal is to isolate this term right here with the variable exponent, and then we can use logarithm, the appropriate logarithm, to get x isolated. Now let's go ahead and do that. Multiply both sides by 0.04. 0.04. The left side divides out. So we have 1.04 to the x power equals, now this is not difficult to multiply. You just multiply 50 times 4, which is 200, but you have 2 decimal places in one of your factors, so you adjust your decimal points in the result accordingly. So move it 2 places to the left to compensate for these 2 decimal digits here to the right of the decimal point. So we have 1.04 to the x power equals 2. Now there is no way you can express these two exponents as terms with identical bases. So we have to use the common log or natural logarithm to enable us power down this variable exponent for isolation. So if you want to use natural log or common log, it doesn't really matter. I will be using natural log for this problem. Okay, so let's go ahead and do that. I'll have the natural log on the left side of 1.04 raised to the x power equals the same thing on the right side to preserve equality, the natural logarithm of 2. On the left side, we're going to power down this exponential variable term here down, so we will have x times the natural logarithm of 1.04 equals the natural logarithm of 2. Now to get x isolated, we will go ahead and divide both sides by the natural logarithm of 1.04. Okay, so on the left side we have some cancellation action happening, and then the final results, we'll enter this quotient into our calculators. Okay, so we are going to enter the natural logarithm of 2 divided by the natural logarithm of 1.04. Okay, our answer is 17.6730 to 4 decimal places. So let's write that down. 17.6730. Okay, let's move on to the last problem, question number 6. Okay, so for problem 6, we have, let's say we have 45 divided by 1 minus 4e to the negative 0.03t equals 900. Okay, so let's go ahead and solve this exponential equation. In order to solve this exponential equation, our primary goal is to get this exponential term isolated first, get rid of the 4, the base, and then the negative 0.03, and we'll have t isolated. When we get to that state, we are done with the problem. So let's go ahead and do it. Now we have a variable in the denominator, so that could pose a problem. So let's go ahead and resolve that issue right now. I'm going to express 900 as a fraction. And to clear out the denominators, I will cross multiply the bottom left to the top right and the bottom right to the top left. When we cross multiply, we'll have 45 equals 900 times 1 minus 4e to the negative 0.03t. This looks much better now. How is that possible? Well, the term with the variable exponent is now in the numerator. That's preferred. Okay? So to get this term isolated, we're going to get rid of the 900 first. We'll do that by dividing both sides by 900. So divide by 900, divide by 900. On the left side, we can reduce this. 45 goes into 90 twice. 45 goes here once. 45 goes into 90 twice, but we have a 0 there, so it's 20. On the right side, the 900s divide out. So we have the result 1 over 20 equals 1 minus 4e to the negative 0.03t. Next move to get this exponential term isolated involves eliminating or getting rid of the 1. So we'll proceed to subtract 1 from both sides of my equation. Alrighty, so we have 1 over 20 minus 1. If we find the LCD of 1, it's going to be 20 over 20. Just multiply top and bottom, write this as a fraction, and then times it by 20. Equals negative 4e to the negative 0.03t. Now on the left side, if we subtract 1/20th from 1, or subtract 1/20th from 20 over 20, we'll end up with negative 19 over 20. And that's equal to negative 4e to the negative 0.03t. Now how do we proceed? We're zooming in on this variable exponent right here. So we're working our way from outside inside. So negative 4 is the next number to be moved to the other side. Since it's been multiplied here, we'll just simply divide both sides by negative 4. Okay, so on the right side, this divides out, and then we have negative 19 over 4. We can just enter this into the calculator, okay, or we can divide, but let's just enter it into the calculator. So we have e to the negative 0.03t equals parenthesis negative 19 divided by 20. So that's the numerator divided by negative 4. Okay, when you carry out that division, you have 0.2375. It's going to be positive. Okay, 0.2375. Now, clearly, we cannot express these two terms as identical exponents, exponents with identical bases. So we have to use logarithms to address the situation. Okay, we're either going to use natural logarithm or log base 10. So let's use natural logarithm here. So we're going to take on the left side the natural logarithm of e to the negative 0.03t equals, on the right side, the natural logarithm of 0.2375. On the left side, what you see is something nice happening. Natural logarithm is log base e, and the base of this exponential term matches the base of this logarithmic function right here. So guess what? They cancel out. So on the left side, we have negative 0.03t equals the natural logarithm of 0.2375. To get t isolated, we're going to proceed to divide both sides of our equation by negative 0.03. Okay, divide both sides by negative 0.03. On the left side, we will see that we have accomplished our goal. T has been isolated when the negative 0.03 cancels out, so we have T as approximately. Now we're going to be using our calculators to compute the result of this quotient statement. So we have the natural logarithm of 0.2375 divided by negative 0.03. So our answer is 47.9196 to 4 decimal places. So let's write that down, 47.9196. Thank you so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your study of exponents and logs, do give us a thumbs up. Your positive feedback is very valuable and supportive to us. If you have any questions or comments about this presentation, just include it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.